Okay, hello. So I will be talking about testing Qubes OS, and this is specifically tricky because a lot of tools for testing software use either some containers or virtual machines and things like that, but Qubes itself also runs virtual machines. So run virtual machines nested in another virtual machine is kind of tricky. Okay, so first of all,
Marek?
who am I? Yeah.
Excuse me, like you are distorted. I believe like there is still some problem with bandwidth, or I don't know. Like your voice is distorted.
Oh, but okay. Maybe I'll close this one. Should be better now. Okay, so I'm open source contributor, developer, CTO of Invisible Think Lab, and project leader of Qubes OS. And I will be talking about how we can approach testing, and then when to run different type of tests. So let's start with how. First of all, we start with a bunch of unit tests, which test a single component. As Frederick shown in previous presentation, we have over 100 different repositories. So in many cases, a feature is built from multiple components. But still, we can test individual functions, individual scripts separately. And this is good for for noticing some regressions early. And also this is very fast because you just need to run one software component locally. Currently we use Python unit test for that. Even also for non-Python components, we use Python unit test as a unified framework for running tests. In some cases, those tests are simply running external tools that perform actual tests, but this way we have some uniform way how to run those tests and how to collect results and stuff like that. In some components, we also move to PyTest because it's more convenient for Python software. It's about we use async IO a lot, and PyTest have better support for async IO. And we can, for example, run those tests in Travis CI, and this is example how it looks like. There are over 600 tests run in just over a minute. So it's very, very fast way to test. In some components, we also measure test coverage, and we also see if the feature we are just adding or the bug things we are just adding, is it covered by tests? So this is something that is very similar to any other software component. And then we have a bunch of linters. For Python, we use plint. For shell scripts, we use shell check. We also built most of C components with W error flag, meaning every warning is a build error. So this is also something we put into Travis CI. Then for some components that are specifically exposed for untrusted data, things like QRexec services, QRexec itself, and other cross-VM communication tools, we have fuzzing tests. These attack the service with a lot of random data and see how the service behave. We do that using Google's OSS Fuzz framework. They provide both tooling and infrastructure to run those tests on. So this is a very nice service from Google. So this is yet another test, but this is while some of those previous tests, unit tests, linters are running before code goes in. This is actually run on master branches of the components, so something that already merged. And of course, when we use Travis CI, we also do basic build tests, so to see if the component built at all. This catches simple errors like forgetting to add a file to make file, to spec file, some typos and stuff like that. Interesting thing is we also do build tests for our website. We host our website on GitHub pages, and we have Travis job that do build test on each pull request to the documentation to the website, including running a spell checker on the result. So we have Travis job that do spell checking of our website. Okay. And this is example how Travis CI output looks like. So there are a bunch of tests for different distribution. As Frederick said, we support packages for multiple distributions. So we build test for them all. Here is for DOM0 and for Fedora and Debian VMs and also CentOS. I think this is kind of outdated because there's now CentOS 8 and Fedora 32, but yeah, it looks similar to this one. Okay, and after those basic tests, which focus on a single component at a time, we also do integration tests. Those tests take the whole Qubes system and run tests on the system. This includes creating a bunch of VMs, trying calling services, QRexec services between VMs, some things like file copy, things like starting application, checking if networking works, a lot of stuff like this. And similar to unit tests, we use Python unit tests as a framework, which also may mean the actual tests are in something totally different, but they are called from a Python unit test to have unified way to collect results. In some cases, we also run tests within VMs. Tests are orchestrated from DOM0, so the Python unit test is running in DOM0, and some tests are simply calling a script in a VM. One example is testing split GPG and Thunderbird. So the test simply starts a Thunderbird within a VM and start a script that interact with that Thunderbird to see if split GPG still works. So those tests, as I said, they are running in DOM0, and they're quite aggressive in what they can do to DOM0. So this is this should be run in a environment specifically for testing. Running this on your main machine or your development machine where you also keep your important data is very bad idea, because we try very hard to clean up after the tests, which also means aggressively removing everything that was created during the tests. So it's quite easy to lose some data if you keep it in that environment. And we have two approaches to run those tests. One is manual, like you do some changes to the system, to your test system, or build new packages and install them on your test system, and simply call Python Qubes test run. I think I have a screenshot for that, like this. This test runner replaced Qubes D service, so it requires first to stop Qubes D service, run the test, and then start the Qubes service again. And this is how you call it. And as you can see here, those tests are much slower. There are just 23 tests, and it took over half an hour to finish them. This is because every test use separate set of VMs. So there, for each test, set of VMs is created. Depending on the test, it may be one VM, maybe two, or for some networking testing, some complex network topologies, I think we have tests, the individual tests that create 4 different VMs. So it simply takes time. Another way we can run those tests is using openQA. This is quite amazing tool developed to testing the whole operating system. So the basic idea is it's a VM with connected some specific ISO image or disk image or whatever you want, or maybe some network boot or something like that. And then interact with the VM through VNC and serial console. So there is the whole interaction with the test system is exactly as user would do that. So if you want to click trigger some action, you need to click through the menu or enter some command or something like that. There are no specific agents inside this test environment. Additionally, there is a bunch of tooling, the framework to write those tests. This includes both tests running a specific command, so we can, for example, SSH to the environment, to the machine, which is not really working in Qubes because we don't have network access to DOM0. But you can log into through serial console and run some command, or you can also click on the screen, and there is a whole framework for comparing screenshots if the expected things is visible on the screen, but also to find various GUI components. So things like this is how OK button looks like. Please find me it on the screen and click it. So this is a very powerful tool. And yeah, we use it. Initially, we used it for testing Qubes installer to run the whole installation process inside this openQA. openQA is running KVM specifically, by default at least, and it was kind of challenging to get Qubes running within KVM, but we've managed to do that, and it's not very reliable. Like this is very because it's in a virtualized environment. It's also kind of slow, and we hit a lot of race conditions because of that. I think I don't know. The last one was last week, I think, some race condition in Zen. So this also introduced some problems, but generally saves a lot of time because testing installation is very time consuming. Single installation can take half an hour or something like that, 20 minutes, and we have multiple configurations that we support. So using automated way to test that saves a lot of time. But then when we integrated those installation tests, we realized we can also run the whole integration tests within the openQA. Still, it is slow, but it does not require developer attention. You simply run those tests, start those tests in the evening, and in the morning you have some results, maybe in the early afternoon or something like that. So yeah, this very saves a lot of time. For integration tests in openQA, we run the same set of tests, but we use different runner. We use Nose2 as a test runner, which is also compatible with Python unit tests. This is because Nose2 runner can export test results in XML, which we can import back to openQA. So we have a unified way to present results. So we have just one place for all tests running in openQA to see all the results. And when to close the whole cycle here, we also have a script that extract test results from openQA and post it back to the GitHub to places, to things that was tested. It may be some pull request, it may be some issue about an update, because we also track package updates in GitHub in specific separate repository as issues. So we have everything posted back to GitHub in a nice report. And this is how openQA overview looks like. So we have a bunch of test groups, and for each group you have various builds you test and a summary of the results. And for each of those builds, we have a list of test jobs. So here you can also see a red or green dot, which, okay, green gives you some information, but for red one, this is actually the whole group of tests run as a single job. So from this view, you still don't see what went wrong. You need to click on this dot, and then you have results. Okay, here I have some successful results, but if anything goes wrong, one of those lines will be red, and you will see what happened. Here you can also see a bunch of screenshots from the test for different test stages. So this particular test is about running an application from the menu. So in the bottom row you can see, maybe, I hope you can see, there is an open menu, and then there is an open application. So this interacts with the system as the user would do that. Okay, so this is how we test. And now we have question when to test, because some tests we can run before code goes in, before merging into master branch, and some can be tested later of already merged code, already released codes, some candidates, updates, and stuff like that. So for pull requests, we use mostly Travis CI to run all those tests that can be run outside of Qubes environment. This includes linters, build tests, unit tests, and stuff like that. And also, for some more complex changes, we run full integration tests also for pull requests that are not yet merged. We do that by marking labeling pull requests with openQA pending label, and then we have a script that collects all the pull requests with this label and configure Qubes builder to build components with such pull requests, configure it to use branches pointed in those pull requests, and then we launch the build. This results a bunch of packages. We have another script to create a repository, updates repository with those packages, and then we run tests where the first step is installing those updates. After updates are installed, then disk image with all the updates to be tested integrated is uploaded back to the openQA server, and then the whole set of test jobs is started. It takes several hours, but still, this is time that you don't need to look at it. You only need to later look at the results. So this is, I think, current view of pull requests with openQA pending label. As you can see, there are multiple of them, so we can test multiple changes at the same time, but also we can easily test a single feature that consists of several repositories. Like here, there is support for audio in HVM domains, and this consists of 3 different repositories, so we can test them at the same time. Then, after the change is tested, after we merge it, we also have 2-step update process. First, when we release an update, it lands in current testing repository. Users can enable this testing repository to test some individual packages or test all the future changes. We also can run automated tests on this specific repository, which includes all the packages that will land as an actual updates later. We also perform some tests manually on physical machines to make sure that we don't break any hardware compatibility, especially for certified hardware we have. So packages stay in this current testing repository for at least a week. We have some scripts that enforce this package needs to be at least a week in the current testing repository. And after that time, it is still manual decision if that package is considered working to be uploaded to current repository, which is what Qubes installation by default pull update from. And you can see on one of the updates, here is a summary. Summary is quite long, and it starts from failed tests section. So it may look like there are only failures, but later there is also a section that lists tests that failed previously and now are fixed. And there is also a section what failures are new compared to previous version, because there are some tests that do fail currently. We don't have all green lights state. Some of them fails because some tests are unreliable because of those race conditions I mentioned before, but there are also some known issues. We do have tests, but we don't have a fix yet. This, for example, applies to group tests you can see on the bottom of this slide. And then another category when to test is during installation. As I mentioned, we do a bunch of different configurations during installer tests. So we do that for every new release candidate, but also from time to time we build some intermediate state with recent updates. You can use that as nightly. Well, it's not every night, but kind of nightly build. And the result of those builds, if installer tests says it's okay, then resulting disk image of specific test is saved to use later as a base for testing updates. We also do that similar approach for testing new templates. We start either from installer image with new templates included, or install templates as an update, and then run tests on those templates. And then we also test on physical machines. This currently is, well, you can run the integration test suite, and we do that too, but also on various hardware-related features are not tested automatically. Things like system suspend, or if NetVM works, or USB VM works, keyboard switching, some external devices, sound, microphone, and stuff like that. We test all this stuff currently manually, and this is something that we would like to improve. Okay, so regarding missing parts, testing on physical machines, this is something that currently is not automated as much as we would like to. I've done some experiments with openQA and an Intel AMT backend. So instead of running tests on KVM, we run a test on physical machine and connect to it through VNC exposed by Intel AMT. This is not perfect for two reasons. One is that Intel AMT limits very much set of hardware we can test it on. For example, for certified hardware, we have AMT and most of ME disabled at all. So it simply doesn't work there. But also, AMT is quite unreliable, at least when you are connecting to it from Linux, from some open source tools. While VNC kind of works, emulated disk and control like that barely works. You rarely manage to boot the system. I've tried some approaches to network installation on local disk and then ensure that tests are run in the proper order, but this means you need to reinstall the system a lot between tests, and also controlling the system through AMT is kind of limited, because also serial console sometimes works and sometimes not, and it's kind of pain to interact with it. Another things that we would like to improve is collecting and analyzing test results. Ideally, we would have all the tests succeeded in all released version, but currently we have much more tests than we have some unreliable tests, but also more tests for things that are not yet fixed. And also, when something new fails, we would like to know what exactly is the context of this failure, because just an example. We have a test that starts GNOME terminal in various VMs. And we run a test like this for every template installed in the system, which include various Fedora version, various Debian version, Unix, and sometimes other templates. And we would like to easily see if the failing thing is related to GNOME terminal in every template, or is related to all the GUI stuff failing in Debian template or stuff like that, to easily correlate failures, and also to see when it started failing. So we can observe, we can find what caused those failures, and when fix also was introduced. Things like that. openQA provides some of this, but only on the granularity of a whole job, test job, which consists of several individual tests. So it's not very useful. And also would like to improve some test reliability, because running tests in a virtualized environment means they are running kind of slow, and this cause hitting race conditions a lot. But there are also some hardware-related emulation related problems, like emulating IOMMU. This is something that works on KVM on Intel. Well, not perfect, but I think good enough. But on AMD, it doesn't, at least not enough to start Zen. I don't remember exact thing, but there is simply some missing parts in the QEMU implementation of IOMMU. And fortunately, or unfortunately, we have openQA workers on both Intel and AMD. So we need something that works on both. This is, I think, some of those issues could be improved by running tests on physical machines, but we would need a way to automate that, because currently we do that manually. Okay, so that's all I have to present. Are there any questions? I think so.
Yeah, that was great. So yeah, I have a ton of questions. Like I took a lot of notes since you know, like maybe not everyone knows, but at some point I did validation of low-level stuff in Intel, and I'm like, all my life is kind of interrelated with validation systems. And of course, in 3MDep we have our own based on RTE, and we test coreboot, UEFI, and firmware stuff. So definitely all this stuff is very interesting. But maybe I will start first with openQA. It's in Perl, isn't it scary?
Yes, it is in Perl. Well, you can write that framework for writing tests is very nice. So you basically you may not even notice it is in Perl, because you have things like assert screen, name of something, assert click, right click, type string, and there are a lot of convenient helper functions that allows you to write tests very easily. If you want some more complex tests, yes, you need to know Perl syntax.
Is it possible to kind of
basic?
Yeah, Marek.
Yeah, please continue.
Yeah, I just wonder if it is possible to kind of chain to other framework. So we're using robot framework because we're mostly using SSH, Telnet, and like those serial libraries. And it's kind of, it also has integration with Selenium. So it's kind of, we use that part. But it's question if openQA can kind of chain to other environment and say like I want to execute like this kind of stuff, and I have well-defined output of this stuff to know if it failed or passed.
Yes, definitely. This is exactly what we do with integration tests. We run tests based on Python unit test inside this VM with to start those tests. We use openQA primitives to run a command in the terminal, but then we simply run the command, collect its output, and send it back to openQA to list as a result, like what tests succeeded and what tests failed. And also openQA supports a bunch of test result formats, so it can understand. I don't remember exact list, but I think we use JUnit XML syntax to import test results back to openQA.
Okay. Moving forward with the questions. So KVM, it's like very interesting part because it opens the door to Power and RISC-V. Am I correct? And it's like I assume like we can, thanks to the quality checks and quality tests you have, any port will be able we will be able to test any other port to make sure that the features work similar, the same in those ports.
Generally, yes. There's definitely there will be still a lot of things that are specific to different ports, different architectures. But yes, generally, you should be able to run KVM on different architecture, and openQA supports workers for different architectures. So you actually can select that which tests should run on which environments, and it can schedule such tests. Currently, we run only on x86 64 bits, but yes, it definitely supports multiple architectures.
Yeah, I'm asking that because in light of all these bounties and all these efforts, it would be interesting to say, okay, to close that item in the project, if this is like, for example, community-driven project or some foundation-driven project, you Marek just can say, okay, so to close this item, you just have to pass this set of tests. Just for different for Power or for RISC-V.
Yes, definitely. This is something that should be easily done. We also it is also possible to add another worker and run the same tests on different configurations. So we can simply set up a test template that says run the exact same step on a different architecture and see if that works. Yes.
Okay, so next you complained a little bit about the speed, that the whole solution is a little bit slow. What's the main reasons for that?
I think mostly emulated devices. We have with nested virtualization, we have emulated EPT, I think, and this slows memory access a lot. We also have emulated network card, which means network access is very slow. And we've tried with emulated IOMMU. Currently, it's still not enabled in a production instance, but this is also not very fast, I would say. But during the test, we start a lot of VMs, and this also use disk a lot, and the emulated disk in KVM is also kind of slow. And because we want to use as configuration as similar to the real hardware as possible, we do use emulated disk instead of things like virt.io, because we want to test things that is not aware of virtualization. For example, I don't think we can assign virt.io network card to a NetVM within Zen running within KVM, but we can do that with emulated one.
In fact, we can. I just recently found that we can. Latest attempt of the latest Zen is working. So I just found last week. I was surprised because I forgot to switch the network card type to Intel, and I said, "Oh, it works," but it's just recent.
Yeah, so I know that.
Very slow.
Okay.
I know that we have Andrew Cooper from Zen Project here. Andrew, so can we just leverage some hardware features? I know, like, isn't something like EPT for nested virtualization? Or Marek, you don't want to rely on that, or how? Or maybe I'm confusing something. Andrew, did you heard about something like that? I don't know if
I'm not aware of any specific issues there. I mean, ultimately, you are bound by how well KVM actually runs nested virt, because KVM is the hypervisor that openQA uses. One question I did have from the previous thing: have you tried Zen 4.13 on the AMD hardware by any chance? I think
not yet.
4.11. We almost completely rewrote the IOMMU driver in Zen as a side effect of getting AMD ROM support with X2 APIC. So there were so many bug fixes we didn't even bother trying to backport some of them. So if you try Zen 4.13, you may see a different result there.
Wait, for 13, not 14. Like stable, not unstable, right?
Correct. Yes, anything from 4.11 onwards should be fine.
Yes, we do run 4.13 in openQA.
Okay, so try that with the AMD side of things. To be honest, if there's some small tweak we can make to make this work better, it might be worth doing. Otherwise, you're going to have to get openQA to bug fix their hypervisor. I have no idea what the process for doing that would be.
As you can see, last week there are a bunch of issues, a bunch of race conditions we hit on when running nested in KVM.
Right, but we are doing our best to fix those.
Yes, that's right.
We of course want to make fix bugs as we find them.
Okay, so maybe another question. So as always, standard question: how community can help extending test scope? What kind of tests you envision are most necessary? Yeah, how community can help with that? Or maybe other point of view. If I will add some SRTM, DTRM, fwupd, what kind of tests you would like to be contributed together with it?
Definitely, if possible, some unit tests that can be run outside of Qubes. So we can, for example, connect into Travis, because this is simply much faster way to have fast, quick feedback if the thing works. As for integration tests, one issue with contributing to openQA tests itself is that in practice you need your own openQA instance to run those tests, and setting up openQA is kind of challenging. I think Frederick can tell you that.
Yes, exactly. That's why I'm going to do some salt formula for that, because it's some kind of pita to set up.
Yes, that's unfortunately true. But this is why we have all those integration tests run in Python unit test, because this means you can run them on any Qubes machine. Okay, anywhere you don't care that much about your data. So this is about some test machine, but still, you can run them quite easily by simply installing package and calling one command in DOM0 and not setting up the whole openQA service. And then when you contribute tests like this, it gets automatically included in openQA. So this is a nice feature here. And actually, I do have a list of tests. There's some issue also on GitHub, list of tests that we would like to have. And this also includes having tests for all new features.
Yeah, so all that story kind of brings late launch of the RTM to me, because if we would like to have distributed trusted test results, we may have we can envision signed test results by, just to make sure that the person that's running it is the legitimate contributor, and we may have different trust levels for different test results. Yeah, but this is just I believe this is just off topic, just additional thought.
Yeah, I think this. Yeah, this is something with. I don't consider it that important, because generally I consider a test environment not very trusted, and if I received some test results from some contributor, then that's fine. But still, I would prefer to run tests in a configuration that I know from where it started, and some controlled environment, because there are so many variables that can affect test results. So it's very hard to provide some trustworthy test results.
Yeah, Marek, I hope that you will scale to this according to success of Qubes OS. But I also would kind of see some small risk that that scale of Qubes OS could be bigger than doing that manually or doing that yourself. But anyway, this is just my rambling.
Yes, definitely. That's why we are trying to automate as much those tests as possible. And actually, we've talked some weeks ago about some possibility to automate tests also on a physical machine, which would be really exciting also to have.
Yeah. So okay. So I have three more questions or thoughts. How you link the failures of the tests or bugs from tracking system? How does this link it? And I saw some comments that you place comments and give the link to the issue. But is openQA able to kind of do that more consciously, or I don't know?
openQA itself do have integration for linking specific test failures to specific issues, but this is only about place to provide metadata. It is automatically done if you include link to openQA in your bug report. So if openQA see you got to the test result from some bug report, it automatically linked it. But this is not very useful for actually filling that information. And for that, we try very hard to include ticket references in commit messages. These include both fixes to some actual bugs, but also adding tests. So for each test that is about specific bug that happened, we also have a ticket reference in that in the commit message, and then we have a script that when posting a result back to GitHub looks for all those ticket references in the packages and post it to the right issues.
Mm-hmm. Yeah, that's giving me too small more idea, but maybe I will leave this at the end. Okay, so I believe, like, from our perspective, it was always problem to have good presentation, like a summary, like a meta summary for all tests running and the state of the system. And the question is if you have any ideas or you have any proposals for building kind of dashboard which displays show summary of test results and some trends maybe. I know that massive testing is done by kernel CI, and they definitely kind of did the work to present those results in a, I don't know if this is readable way, but at least to some extent it is useful. What about results of testing Qubes OS based on openQA?
So I think currently there are two things that are interesting. One is the main page of openQA. When you go to openQA qubes.org, there is a nice overview for tests, and there are different groups. Maybe they lack some explanation, maybe. But basically you have tests for base image, like installation image, but then you have a group called Qubes OS update, which is about the current state, the updates that you install, and you see what how many test group are okay and how many fails. And then there is also a group Qubes OS pull request, which is about changes that are not yet merged, that are still in development. And for those pull request tests, we also have a script that extracts those results and post it to specific pull requests. So if you made a pull request with some change, and we decide to also include it in openQA, for the contributor, the thing is very simple, because you simply, when the tests are completed, which takes several hours, you simply got a comment with test summary in your pull request, and there is a specific section, what are new failures compared to previous state. So you see that merging your pull request will result in these new failures appearing.
Mm-hmm. Okay, so one of the last thing I'm wondering, because you said that that provisioning everything and like kind of installing Qubes OS, everything takes time and so on. But what about like having network boot hypervisor and migrate everything, like whole system from different places? I don't know if it is even possible, but it should be kind of cloud use case. Maybe also Andrew can add something to that, if this is like too futuristic, or this is like reasonable to have like Qubes OS. Like I have I'm just network booting hypervisor and just like migrate all states to this environment, just to speed up setup for development and for testing environment.
So currently, for tests that are running on openQA, We use disk images. Like there is some base disk image, which is a result of previous installation test. So we simply download the disk image and start from there. This works only in virtual machines because we can simply download the file and run virtual machine from that. For physical machines, this is indeed something we would need to solve somehow better than installing the system each time separately. And yes, I think something like loading this image to the physical machine would work. One thing that is easier in cloud environment and not that easy in Qubes is that we specifically don't have network in DOM0, which means you cannot really boot Qubes OS from some network disk. You need to have local disk. So that limits this fancy cloud solutions here. At some point we may have separate storage domain with network access to do something like that, but that's several years from now.
Okay. So in 3MDEP we're also using kind of methodology which is called test-driven bug fixing, which means that if you face a bug, you write test, and in that way, and of course you're fixing the bug, then test pass at some point, and then after very long run, you have quite reasonable regression pool. Is this something that would be? What do you think about this idea? And if this is something that community or I know that this is just time, like people don't have time to write tests, but do you think this makes sense?
Yes, and actually we do that too. We are not very strict about this, so if the bug is just a typo somewhere, we simply fix it because it's easy enough. But for bugs that are reasonably complex, we do start with writing and test and checking if this test really fails, if that thing doesn't work, and if it really passes with the fix included. So this is actually we also do.
So can you elaborate a little bit about complexity of that? Because I just wonder, like, how in openQA, like I understand that it depends on the problem, yeah. But is it like, you know, couple hours or a couple minutes or a couple days? Do you have any kind of how much time it takes?
Most of the tests are simply in Python unit tests. So you simply write the test and you on the same machine you test your fix. You can also test your test if that works. And running a single test is just a couple minutes. Writing it, and it's probably 10 or 15 minutes too. So it's not that complex. And yes, this way we built quite a lot of tests. Right now, I think we have way over 1,000 tests in our test suite.
Wow, that's impressive. Okay, that sounds very, very cool. So that exhausts my pool of comments and questions. I don't know, anyone wants to ask questions? Like, I don't know, Michał, Norbert, do you have questions? I see Andrew is not here. But any other questions?
I could have one if the others don't have. In fact, I wonder how difficult that could be to implement some openQA worker running on physical machine, because maybe some openQA guys will know that better than at least me, because in fact we need some VNC session somewhere. So with some server we can have some remote VNC session, even it's not, there is some authentication problem and so on. But if I want to test on my laptop, for example, I would say I would start some PXE server to automate the installation of Anaconda. But at least Anaconda can support VNC session. But as Marek said, we don't have network in DOM0, so we will need at some point to make some hack at a different level of the setup for allowing some remote access of DOM0 desktop, etc. So I don't know how we can go forward this problem with classical laptops, not necessarily a server or machine having some technology like AMT, etc. So have you some idea, Marek or Peter, of how we could manage some physical testing remotely? I don't know. This is a challenge.
Yes, this is indeed very challenging. For servers, actually, I just checked openQA. There is a bunch of server solutions supported. Like there is a IPMI, there is some SVIRT, SPVM, and various solutions like that. But for physical machine, I think the way to go would be connecting some proxy device. Think like connecting to external VGA connector, USB keyboard, emulated keyboard, emulated mouse, and control the test machine using things like that. Something like network KVM. Like thing.
Yeah. So yeah, we kind of took over the maintainership, or maybe not took over, but at least supporting maintainership of MuxPy, which kind of helps in many use cases. Definitely the emulation of the keyboard, mouse, because it has a USB OTG. And you just can, use USB gadget to emulate the devices, expose it to the system, to the hardware system, and then you can use some combination of HDMI to IP to catch the output. But the problem with laptops is how to catch the output. It would have to give ability to kind of provide output, or maybe but BIOS should do that. Definitely, like if this is open source firmware laptop, you can count on us. But if this is closed source BIOS, then the question is if there is ability to kind of say use default output as a as a HDMI output from or DisplayPort or whatever output is in your laptop instead of a regular screen, or at least show on both, show the output on both. Then you can use this HDMI to IP converter. And I know there are massive, like, great projects. Like there are projects for recording the streaming. There are a couple boards for that. Some of them are even completely open hardware. But the problem is most of that is expensive because it requires like quite the big FPGA, because it was created for people that play with video stream, raw video stream, raw HDMI stream. So that's kind of like expensive part of that. But some of them have even 6 or 10 inputs. So it can support multiple, one unit, which costs probably 3,000 USD or something. It can handle multiple. I don't remember the name, but it was like, I believe it was some Australian open hardware project. That's one choice. Other choice is MuxPy, which is way cheaper. I don't remember what's the price. It's on our website, so you can look at it if this will work. And then you have this to IP, and I believe either you probably can somehow deal with VNC, so this whatever you have in this IP packets just like kind of is converted to whatever you can see in VNC, and that's probably your But then the question is, of course, you don't have input. The input have to be completely coordinated with different channel. But yeah, at least there is some output which you can verify. So Samsung used MuxPy in a way that they just compared the screens. So they just had this HDMI. They just did the screenshots and just compare if the screen is the same as it should be. So that was and I know this device is popular in Tizen, Yocto, Open Embedded community.
Okay.
There is also ability to emulate SD card, for example. That's also in some places could be useful. USB storage is of course USB gadget. I believe it can some good hardware testing environment can be built.
Okay.
Yes, regarding control, how to switch output to external HDMI, I think that's easy part, because we can start the machine always using IPXE or similar network boot, and then this bootloader can decide about kernel arguments, actually which kernel to start. Should it be from the local disk or maybe something downloaded? This way we have starting point where we can control things. So I think it should be quite easy to add some boot parameter to and always enable HDMI output.
Yeah, I believe if 3MDEP would at some point because we're mostly doing embedded devices or NUCs, and we typically do not validate UI. But if it will happen that at some point we will have to validate UI, definitely we will invest resources in building such configuration. I believe all pieces are there. We just have to glue everything and connect to some validation system, which is proven to work. And for Qubes OS, I believe this is probably higher priority right now than for us. But who knows? Maybe by the Qubes OS Mini Summit 2021, we could have something, or we can present something that's already working.
So in fact, if I understand what you said, yes, Marek, please.
I just wanted to say that openQA is quite good job scheduler and tool to orchestrate this, whatever the backend will be. Mm-hmm. Because all the test running, comparing screenshots, scheduling job and stuff like that is already there.
Okay. Frederic?
Yes, just to be sure if I understand, I don't know MuxPy, but from what you said is that we can use MuxPy to some kind of interface between any laptop I have and any remote controller, if I can say so, to interact with the laptop if I will be a user with some mouse, with some keyboard and screen. Is that the
yes.
goal of MuxPy?
Yeah.
Okay,
yes,
because
exactly.
this is exactly what we need for openQA, for example. If we can manage to make some kind of worker, MuxPy worker, if I can say so, that will be, I think, a very step forward for plug and play laptop testing and even other computer, other desktop computer, etc. So I think we'll have a look to that. Yeah.
Sure. Yeah. Yeah. So feel free to look at the
actually,
MuxPy.
I have written openQA backend. Yes, writing openQA backend is not that hard. I have written the AMT one, which is, well, AMT is not reliable, but actually writing a backend requires you to know Perl, but then it's kind of easy.
Okay. Okay, just Perl. Let's move on
just
to let's move on to to kind of summary of this mini summit, I'm like Marek, I'm Frederick, I'm very happy that that you are here. We should like that you presented, that you commented previous presentations, that you were willing to join us and kind of like agree that we're doing that together again. It was so apparently the gains from 2019 Qubes OS mini summit are that we started fwupd for Qubes OS. So there is at least one project that we discussed and we were able to start to execute on. And yeah, like we definitely will promote as a 3M dev Qubes OS. We have customers that asking about that definitely asking about certification, that want open source firmware. That's why I believe the synergy is quite big. You're also promoting open source firmware. You probably like more open source firmware than proprietary one, since the certification requires that. But I would like to thank you for that. I also would like to thank people that are not here, Daniel Smith and Andrew Cooper, who joined the call and also answered the questions, helped in creating and reviewing presentation. And I believe that was great mini summit, and I would be glad to do it again in 2021 if you are okay with that. But then we probably should start talk a little bit, at least 5-7 minutes, about what we can envision in this year to happen, and like what we would like to, how we would like to see the 2021 Qubes OS mini summit if we want to do that.
I think the idea to have an event like this is very good. I like it very much. And to be honest, I think having an online event is better than having physical, because it allows many more people to participate in the discussion, which was not the case last year, which was just 4 of us, if I remember correctly. So I think this format of the event is much better, especially for quite small event. What was that? 10 hours in total or something like that. So it definitely does not it's not a good excuse to travel or something. So yes, thank you very much for organizing it and put this.
Yeah, only that's only me or other.
No. It's totally disturbed.
Yeah, Marek, like your voice is like distorted. I believe like another like bandwidth stuff or something like that. Like it's hard to understand what you said.
Okay, let me try it this way. Okay, so I just wanted to say I like this format very much, like the online event, because it allows many more people to participate. And also thank you very much for organizing it, and let's keep doing it in next year. And
yeah, so what do you think we can achieve, like if you would like to choose something from this Qubes OS mini summit that will have like maybe not commitment, but at least what in your opinion have the biggest chance to be contributed or developed over this year, so we can, for example, next year continue given topic, because like it happened by itself with fwupd from 2019, that it evolved, and definitely this was one slide, I believe, or 2 slides back then, and of course Trenchboot evolving, that's normal stuff, and like I believe this will not change. Trenchboot will evolve, and like there's no discussion about this thread. But what other topics are kind of for you promising, and we should think about expanding that?
I think from all those topics, the biggest potential is all kind of boot measurement related topics, because currently this is a thing that Qubes is very limited. We have anti-Vil Maid, which supports only legacy boot, only TPin 1.2, and only Intel. And this is an area that could use a lot of improvement. Adding support to UEFI, TPM2, AMD, any of this would be very, very much welcome.
Yeah, so I believe like our dream is also to have this year trench boot plus core boot plus STM, semi-transfer monitor on some probably Dell machine. I'm not sure yet. And I believe like Michał will work on that and Christian. So we will see if this would be possible, maybe on top of that Qubes OS. And then we can see how this will perform, how this will work. And maybe this also would be kind of topic to expand on. Okay, so I believe I will not. It's like we coming to 6:30. There is not much people left here, but still there are some survivors. I don't see any questions. There are some comments from Dominic. He say like it's really interesting. Yeah, I do not have any questions, but he mentioned HDMI to USB open video capture hardware plus firmware. So this may be interesting for our test bed. And he said that you could do a rotation between online and in person. I'm not sure what he's referring to. Yeah. So I understand that this is probably comment, Marek, to your.
Yes. It's about the form of the summit.
Yeah. So yeah, in person is good for like having some beverage after and like have some topics behind the curtain, which is always good to establish better relation and so on. But online is also good for marketing presence, for advertising, and like kind of maybe spreading the word about Qubes OS and like showing people that it is possible to contribute. It is not so hard to contribute, and there are plenty of areas that Qubes OS looking support for. And there is of course some interrelation between, or there is some important boundary that we should check between the firmware world and the operating system world, and a lot to leverage on that boundary. Okay, so any final comments? We have 5 minutes left, and I believe we should trying to close.
Yeah, from my side, I'm very happy about this event. I think that a lot of interesting topics were here, and yeah, and thanks again for organizing.
I agree. Yes, very interesting topics, especially for my side. I like the initiative of developing open source hardware, and maybe one day we can have some serious open source processor, motherboard, etc., to leverage our knowledge of having some secure basis from the low level aspects to the higher level aspects. And this is why I take the train of Qubes OS 4 years ago, because I was concerned of such topics, and there is a lot of things to do, things that I don't know, things because developing hardware is certainly very difficult. So I think there is very interesting things to explore and to develop in the future. Yeah, so nice, very nice.
Thank you, Frederick. Michał?
Maybe one suggestion for next year. Maybe let's make the presentations less geeky and nerdy. And
is it possible maybe... even?
Yes, for an engineer, quite nearly impossible. Yeah. I just realized that the last week's presentation could be too heavy.
Yeah, I believe like our work is to simplify things for regular users. If we can, I believe Qubes OS also has these goals to have this interface and make provide a secure, reasonably secure operating system that works for regular person, not extremely paranoid and like very knowledgeable people, but maybe extremely paranoid, but not exactly very technically how to say that, experienced. No, they do not have no like internals of hypervisor to run Qubes OS. So anyway, with that comment, thank you very much once more time, and like I wish you all the best in the year for evolving all the areas that we care about: operating system, relation with firmware. Let's hope for open hardware, and let's hope for more open source firmware.
Yes.
Thank you very much.